single playing card costs only a few cents to make, yet it sits at the heart of a $250 billion global casino industry. From poker tables in Las Vegas and Macau to elite tournaments with prize pools worth tens of millions, every win, loss, and life-changing bet begins with the same 52 cards. Each is cut, printed, and finished with near-perfect precision. So how does simple paper become the casino world's most critical tool? Let's explore the hidden factory process behind it. Support the channel, hit like, subscribe, and stay tuned for more amazing content. A single large casino can consume nearly 300,000 decks of playing cards every year. At the table, players may only see a few decks rotating in use, but behind the scenes, a very different reality exists. Inside a casino, the lifespan of a deck is far shorter than most people imagine. Casinos willingly replace decks that cost only a few dollars to protect cash flows worth millions every single day. In this environment, playing cards are no longer simple tools for entertainment. They become instruments of risk control. Even the slightest uneven surface, subtle curvature, or change in texture can affect dealing, shuffling, and probability itself. When risk outweighs cost, cards become both the cheapest and the fastest replaced assets in a high-value monetary world. So when you pick up a deck of cards, which game do you play most often? The production of playing cards begins in the design room, long before any materials reach the factory floor. Technicians and designers work entirely on computers, constructing the deck digitally, one card at a time, using specialized design software. Standard dimensions, print layouts, cut lines, and safety margins are defined from the start to meet the strict requirements of industrial printing and cutting equipment. Designers first establish the deck's visual style, giving special attention to face cards like kings, queens, and jacks, which must appear correct and upright regardless of orientation. Numbered cards demand extreme precision, with suit symbols, sizing, and typography perfectly consistent. Card backs require absolute symmetry to prevent identification during play. Before leaving the design room, every detail is scrutinized to ensure no identifying marks are visible when cards are rotated or flipped. Lines, strokes, spacing, and weights are checked on-screen at true scale and test-printed. Final files are exported under strict factory standards and repeatedly checked for resolution, color accuracy, and potential misalignment. Production then moves to the factory floor, starting with base paper preparation. Playing cards may seem simple, but they begin as multi-layer paperboard made from refined cellulose. Thin layers are bonded with industrial adhesives to form pasteboard, allowing precise control over thickness, stiffness, and flexibility. Many decks include a dark core to block light and ensure uniformity. After lamination and flattening, the paper is calibrated to 8.9 to 9.7 ounces per square yard. From here, production follows either sheet-fed or roll-fed paths, with polymer coatings and optional embossing applied for durability, smoothness, and optimal handling. Once paper preparation is complete, the sheets are ready for printing. In sheet-fed systems, pasteboard is pre-cut into large sheets and fed into offset printing presses, one of the most widely used technologies. Images are first transferred onto a rubber blanket before being pressed onto the paper. Operators carefully mix inks, often oil-based or specially formulated for adhesion and color stability, loading each color into separate rollers and spreading it evenly before contact with the sheets. In high-volume roll-fed systems, laminated paper rolls are continuously pulled through printing units. Cylindrical printing drums carry the card images, receiving precise ink supply, ensuring consistent, high-quality printing while maintaining speed and accuracy across millions of cards. Ink is precisely metered by rollers and doctor blades, applying only the exact amount needed. Cards are printed in multiple color layers, with each unit handling a single color. After each pass, the paper moves through a drying stage, using heat or ultraviolet light to dry the ink rapidly and prevent smudging before the next layer. Yet even after printing, the sheets are not true playing cards without finishing. A protective coating is applied evenly by specialized rollers, locking in the ink, creating a durable surface, and preventing warping, sticking, or loss of smooth shuffling performance. The coating also protects the underlying paper structure, and its thickness is carefully controlled, as even slight variations can noticeably affect a card's snap. Before cutting and shaping, sheets undergo rigorous inspection. Operators and automated systems check color consistency, ink adhesion, finish coverage, and overall flatness, removing any defective sheets. Once approved, the sheets move to cutting. Standard playing cards measure 2.5 by 3.5 inches. Large printed sheets, carrying dozens or hundreds of card faces, are fed into high-speed industrial cutters, using either linear multi-blade systems or custom die-cut molds. Die-cut systems can separate all cards on a sheet in one press cycle, while linear multi-blade systems cut consecutively. Modern lines process thousands of sheets per hour, producing several thousand decks per shift. After cutting, cards move to corner rounding, trimming all four corners to a fixed radius for safety, reduced edge wear, and long-term stability. Decks are then assembled using automated counting and sorting systems to ensure all 52 cards are present in proper order. Completed decks are compressed into tuck boxes, wrapped in cellophane, and packed into shipping cartons. Many casino decks bypass retail and go directly to internal storage, where their life cycle is closely monitored. With hundreds of thousands of decks replaced yearly, the question remains, what happens to the paperboard? Even discarded playing cards begin a new life in the recycling process. Once a cardboard box has finished protecting goods, it begins a new journey back to the recycling plant. At the household level, boxes are flattened, bundled, and set aside for collection, while in larger facilities, supermarkets, warehouses, and shops, cartons are compressed by hydraulic balers into neat, square bales for easier stacking and transport. Every day, thousands of these bundles make their way to processing centers. When trucks arrive at the plant, collection ends and inspection begins. Bales are unloaded via forklifts or conveyors, weighed, recorded, and checked for moisture. Optical sensors, guided by human oversight, detect contaminants like plastic tape, metal staples, or stray nylon strings. Overly damp or greasy loads are separated to prevent spoiling entire batches. Accepted bales are then sorted into categories: brown corrugated board, flat paperboard, or printed cartons, ensuring the recovered pulp is carefully classified for the next stage. From the sorting area, approved bales are sent directly to the hydropulpier, the heart of the recycling process. Each bundle is dropped into massive tanks containing tens of thousands of liters of water, diluted to just 1 to 2% fiber. This extreme dilution allows cellulose fibers to separate quickly and disperse evenly, preparing them for refining. Giant rotor blades spin at hundreds of revolutions per minute, creating powerful vortices that break down the multi-layered carton structure while stripping away hardened glues. Inks and thin plastic coatings detach, either floating to the surface or carried away with the water, removing a large portion of impurities. The result is a rough but uniform brownish pulp, the foundation for a new life cycle. To strengthen it, the pulp is further refined. Machines equipped with rotating discs and cutting bars slice and fibrillate the fibers, opening countless microscopic fibrils that bond tightly during papermaking, improving the strength, durability, and quality of the recycled linerboard. Alongside refining, a portion of virgin pulp, produced from wood, is blended in to compensate for recycled fibers that have shortened and weakened through multiple cycles. Additives such as starch, sizing agents, and wet-strength resins transform the slurry into a clean, consistent, and highly bondable pulp, the essential feedstock for forming new sheets of paperboard. Once ready, the refined mixture flows to the paper machine, where the liquid slurry begins taking shape. From large pipes, the diluted pulp spreads onto a moving wire mesh, resembling a stream of brownish mud, yet holding millions of cellulose fibers. As water drains through thousands of tiny openings, the fibers interlace, gradually forming a wet sheet of paper, the first step in the cardboard's rebirth. Beneath the forming section, press rolls continuously rotate, removing moisture and pressing fibers closer together. From this once liquid slurry, the first sheets emerge. As the sheet moves forward, its surface smooths and strengthens, forming a continuous web. Modern sensors monitor thickness, uniformity, and moisture content, ensuring no tears or blotches disrupt production. The sheet then passes through large press rollers, squeezing out remaining water and flattening the surface. At this stage, the paper web has a clear structure, still damp and fragile, but is ready for the massive drying section. Fresh sheets contain more than half their weight in water. Giant steel rollers exert hundreds of tons of pressure, consolidating the fibers and preparing the sheet for final drying and finishing. Sensors constantly monitor the web to ensure it moves smoothly at high speeds, without tearing or wrinkling. Next, the sheet enters the dryer section, a series of enormous polished steel cylinders heated by high-pressure steam to over 300 degrees Celsius. As the paper glides across each rotating drum, heat is transferred indirectly, gradually evaporating moisture, while hot air circulates to maintain precise temperature and humidity. Thanks to this careful control, the sheet's moisture content drops from over 50% to just 5 to 7% by the time it exits, efficient yet delicate enough to prevent warping or brittleness. Once fully dry, the paper has clear mechanical strength and a stable surface. The broad paper web is then fed into the reel section, where massive spools over 10 feet in diameter and weighing several thousand pounds wind the paper into rolls. These rolls simplify storage and transport and serve as the base material for the next stage, corrugating, where the paper passes between grooved steel rollers, reshaping the flat sheet into evenly spaced waves, either smooth sinusoidal curves or sharp V-shaped ridges depending on the design. This corrugated structure dramatically increases vertical compression strength without adding weight, transforming a thin, fragile sheet into a sturdy core with impressive load-bearing capacity. Fresh from the press, these rolls become the backbone of durable cardboard boxes and the essential building blocks of modern packaging. Immediately after corrugation, the paper moves into the lamination stage, where automated gluing systems apply precise lines of hot adhesive to the flute's crests, and flat liner sheets are pressed from above and below. Large press rollers secure alignment and strengthen the multi-layer bond, while cooling fans and support rollers allow the glue to set and stabilize the sheet. By the time it exits, the result is strong, uniform 3-ply or 5-ply corrugated board, ready for converting. Sheets then advance to cutting and forming, transforming flat material into three-dimensional boxes. Semi-manual or automated systems guide sheets through rotary blades, creating precise grooves to mark box flaps. The sheets enter the creasing section, where gentle pressure forms fold lines, allowing the corrugated core to bend cleanly without cracking. Every parameter, from groove spacing to crease depth, is carefully programmed and aligned with the original design. For boxes with complex features such as handholds, air vents, flip-top lids, or rounded edges, sheets are fed into die-cutting machines. Prefabricated metal dies, combined with pressure from rotary cylinders or flatbed presses, cut the entire box in a single stroke, including intricate details like locking slots, cord holes, or angled joints. Once formed, carton blanks are stacked and scanned by sensors to ensure uniformity before moving to the printing stage, where brand logos, barcodes, handling instructions, and other markings are applied. Flexographic printers with soft cylinders apply raised prints, controlled by automated systems that maintain high-speed precision and consistent ink adhesion. Optical sensors continuously monitor sharpness, ink adhesion, and drying in real time. Once printing is complete, the surface is cured with UV lamps or forced hot air, stabilizing the ink and preparing the cartons for final finishing. Sheets then move into quality control, the final checkpoint before leaving the line. Specialized equipment measures vertical and edge compression strength, while sensors scan for uniform thickness, ensuring every box can withstand stacking and transport. Flatness and overall consistency are verified, and any boxes failing standards are immediately rejected. Approved cartons are fed into high-volume packing systems, where automatic folding machines flatten and stack them into bundles with preset quantities. Bundles may be strapped, shrink-wrapped, or packed into larger containers. Integrated weighing and counting systems guarantee accuracy, while pallets for large orders are wrapped and tagged, ensuring that every product leaving the factory is high quality, securely packaged, and ready for delivery.